Hello, welcome back to our channel. Today's question is about the calculation of EMF and internal resistance of a cell. A cell drives a current of 3.2 amps through a 2.8 ohms resistor. When it is connected to 1.6 ohm resistor, the current that flows is 5 amps. Find the EMF and the internal resistance of the cell. EMF of a cell is usually given as the sum of the potential difference IR and IR, where R lowercase represents the internal resistance. So this part here represents the lost voltage. So we are going to do our substitutions in this equation. So the first statement, you're given that the cell drives 3.2 amps through 2.8 ohms resistor. So E is equal to current I, which is 3.2 amps, times the resistance there, which is 2.8. And then we have to add that to current, which is 3.2 amps times the internal resistance R. This simplifies to 3.2 times 2.8 is 8.96 plus 3.2 R. So let's have this as our first equation. Now for the second equation, we are going to use the next statement. When it is connected to 1.6 ohm resistor, the current that flows is 5 amps. So again, we'll say A is equal to 5 times 1.6, 5 for the current, 1.6 for resistance. And then we have to add that to 5R, that is IR. And this simplifies to, so 5 times 1.6 is 8 plus 5R. Now this is our second equation. So we're going to solve the two equations simultaneously in order to get electromotive force A and the internal resistance R. So because the two equations are both equated to E, that means we can equate the right-hand sides of the equations. So we have 8 plus 5R for the equation 2 equated to 8.96 plus 3.2R for the first equation. Now, if we take 3.2R to the left-hand side, we'll have 5R minus 3.2R. And then taking 8 to the right-hand side, we'll have 8.96 minus 8. Now, this is 1.8 R, which is equal to 0.96. Dividing both sides by 1.8, the internal resistance R should become, now that is 8 over 15 ohms. Or if we wish to have it in decimals, that is just 0.53 recurring ohms. So that is for the internal resistance. In order to determine the electromotive force, that is EMF, you can use any of these equations, the first or the second, to determine E. I'd prefer the second one. It looks simpler. So we'll have E is equal to 8 plus, that is 8 plus 5R, and R we already have as 8 over 15. So working out this should be 8 plus 8 over 3. 8 over 3 is 2 and 2/3. So when you add this, you just get 10 and 2/3 volts. If we wish to have it in decimals, that is just 10.6667 volts. And therefore, we have the electromotive force and the internal resistance of the cell just as had been required in the question. With that, we come to the end of the solution to this problem. Thank you for watching. See you in the next video.